Welcome back. My name is Satyajeet Sahu and we are in middle of monsoon series. In monsoon series, we are solving the important portions of your GATE examination. So let us welcome our participants. Welcome Rahul, Juhi, Rasmita. So we had a break, means break for me. Yes, there were other teachers who were teaching other important subjects. So last week we didn't had any YouTube class for me. So I'm back. So this week we will have highway engineering. Okay, hope you have enjoyed the lectures by other teachers. Okay, so today we are going to start highway engineering for this week, and we have power packed sessions for this week. Today we have in traffic engineering traffic delay model. Yes, so many students search for this topic, okay, and they are little confused in this topic. So I decided that let us take this topic so that you can solve the questions in your upcoming GATE examination from this topic. Let us see other topics also, but before that, a short introduction about myself. My name is Satyajeet Sahu. I have 10 plus years of experience in GATE and ESE domain, and I have taught in more than 15 states. I have done my BTech and MTech both from IIT Kharagpur. After that, I have given GATE. I have got a good rank, and through that rank, I have been selected into many of the PSUs, namely DMRC, IOCL, HPCL, and RITES. I worked as design manager in Delhi Metro Rail Corporation, that is DMRC, and I teach all the civil engineering subjects, and I also teach general studies for your ESE prelims. Okay, so more students have also joined, so let us welcome them also. Welcome Aftab, Karthike, Vaskar, Mukul, Vivek, Samriddhi, and Santu. Okay, so let us start the class, but before that, a short plan for this week. So this week, which starts from 1st of August, so an important month has started. Why? Because now we have only around 6 months left. We have only around 6 months left for your upcoming GATE examination. Okay, for the upcoming GATE examination, that is GATE 2023, we have around 6 months left. So time to be more serious and time to solve more important questions for the GATE examination. So I have picked some of the topics which many students face a lot of difficulty and which GATE is asking a lot in your highway engineering subject. So today, that is 1st of August, we are discussing traffic delay model. Then we'll be seeing vehicle damage factor, then floating car method, vertical curves. Okay, now in vertical curves, I'll be discussing the equations. Now in the GATE examination, they're asking some questions on the equations on vertical curves, and students are getting confused. So that we'll discuss on 4th of August. After that, Marshall mixed design, right? And on Saturday, that is 6th of August, we'll discuss super elevation and camber. So these sessions will be power pack sessions, okay? Every day they will be at 5 p.m. Okay, so remember, earlier I used to take classes at 6 p.m., but from now it will be at 5 p.m. Okay, welcome Sasank and Vijit, Bipul, Diya, Survi, Naman, and Anuj. So remember the timings. Every day at 5 p.m. in this particular week, we will have power packed session of 40 to 50 minutes. Okay, we'll not have long sessions. We'll have 40 to 50 minutes. In that, I'll cover the important topics. Okay, so let us start without any further delay. So I'm talking about traffic delay model. So first of all, let us understand an intersection. Suppose we have an intersection. Okay, we have an intersection, and I say intersection, suppose it is signalized intersection. Signalized intersection. Now what is the signalized intersection? Signalized intersection means that there is traffic lights, there is traffic control, right? So suppose you have an intersection like this, right? Intersection like this, where 4 roads are meeting, or I can say 2 roads are intersecting, I can say in that way. Yes, this is a very common thing which you have seen in your day-to-day life, right? So suppose you are standing here, right? You are standing here and there is what? A red light. And when there is red light, what will happen? More vehicles will be queued, right? More vehicles will be queued like this. So I can say vehicles are arriving in this intersection. I will say what? I will say vehicles are arriving at this intersection, right? And that arrival rate I will call as what? Vehicle arrival rate. So I will define a term known as what? V. And what will be V? V will be your vehicle arrival rate. Now can somebody tell me the unit for this vehicle arrival rate? From the name, can you guess what will be the unit of this vehicle arrival rate? Can anybody guess what will be the unit of this? Vehicles are arriving in the intersection at a particular rate. So what will be the unit of this? Any random guess which you want to do? Very good. Somebody answered vehicle per hour. Yes. So this particular thing, it's what? It is number of vehicles arriving, right? It is number of vehicles arriving, okay, divided by what? A time interval, right? Or I can say time period, right? That time period might be 1 minute, 1 second, or 1 hour, right? Like discharge. Very good. So this unit will be what? This unit will be vehicle per hour. It can be vehicle per hour. It can be vehicle per minute, right? It can be vehicle per second, right? Very simple. Now suppose I am saying it's a rate. Rate means what? Rate, I can say it as what? Slope, right? Yes. So if I'm plotting what? Time in the x-axis, and in the y-axis I am plotting number of vehicles arriving. Then I'll get a straight line like this. Right? And the slope of this line will be known as what? Your vehicle arrival rate. How? You see, suppose this is time t is equal to 0, and suppose at time t is equal to 0, no vehicle has arrived, right? Suppose at time t is equal to t, suppose v vehicles arrived, okay? Vehicles arrived is what? V, right? Now, and suppose that time is 1 hour. Now tell me, this will be 1 hour, right? This will be 1 hour, and this will be what? This will be V, right? This will be V. So what will be tan theta? This tan theta will be equal to, what? Your V by 1 hour. This is vehicle per hour. That is what? I can say V vehicle per hour. So this tan theta is what? This tan theta is slope of the line, right? Slope of the line. We know that, right? So I can say that, if I, now I'll erase everything. If I plot vehicles arriving, okay, and then here time. So if I get a line like this, so the V, the vehicle arrival rate, will indicate what? Its slope. Now suppose I am giving you an example. Now answer me this question, okay? Suppose I am telling that vehicle arrival rate is, your 80 vehicle per minute, okay? And suppose time t here is 1.5 hour. Can anybody or many of you can answer what will be this value? Can you answer me? What will be this value? If I am seeing at time t is equal to 1.5 hour, then what will be this value? Can you calculate and give me? What will be this value? Very simple. $720. Paramesh is telling 720. See, it is 80 vehicles per minute. I can convert this into what? I can convert this into 80 into 60 vehicle per hour, right? That is how much? 4800 vehicle per hour, right? Am I right or wrong? Yes, yes. Now you see it is 1.5 hour. So 4800 vehicles per hour are arriving. So in 1.5 hour, what will be this? This value will be simply 4800 into 1.5, that is how much? 7200. 7200. Small mistake, everybody committed, no problem. You understood. So that means if I am seeing this particular coordinate, okay, if this is time t, right? So this will be v into t, right? Right? This will be v into t, right? See, only what I did, I converted this v in vehicle per hour, right? And I multiplied time. Yes, so this is v into t. So from this particular thing, we understood a very simple thing, that if I'm plotting this vehicle arrival, this vehicle arriving, right? And here I'm plotting time, and at a particular time, suppose t, I want to find out the number of vehicles arrived. If I want to find out the number of vehicles arrived, I'll just take the vehicle arrival rate and multiply what? Time. I'll just multiply time. That's it. That's it. I will get this number of vehicles arrived. This is what? Number of vehicles arrived in time t. Hope you have all understood this particular concept now. Now, in the intersection, the vehicles will only arrive or they will go also? They will go also, right? Let us understand that. You see, suppose this is your vehicle arrival rate. The slope is what? V. This is what? V vehicle per hour or whatever, or minute or whatever. Okay. Now you see, here it is time. Now when the signal is red, I'll call this as what? Red time. You see? So when the signal is red, then what will happen? When the signal is red, suppose from here to here the signal is red, is red time. Then what will happen? The vehicles will only arrive at the intersection, right? There will be no departure, right? See, in an intersection, if in an intersection you are seeing and the signal is red, and you are seeing a particular point, you are seeing a particular point, So if it is red, then vehicles will only keep on arriving at that particular intersection, right? When there is red time. When there is red time, right? When there is red time. But after the red time is over, the vehicles will start moving, right? These vehicles will start moving. Somebody will move like this, somebody will move like this, right? Okay. So the vehicles will start moving. Okay. So when they start moving, this is known as what? Departure. This is known as what? Departure. So the vehicle will start departing from this intersection. Now there will be a departure rate also. And the departure rate will be different from what? The arrival rate, right? The departure rate will be different from your arrival rate. So if I plot that particular departure rate, the slope will be known as what? S. And this S will be what? This S will be saturation departure rate. Saturation departure rate. Departure rate. Okay. Now the departure will continue till what time? Tell me. The departure will continue till what time? Can anybody tell? The departure will continue till what time? This is your red time, okay, and then this was your vehicle arrival rate, and this was your departure rate. So the departure will continue till what time? Tell me. The departure will continue till what time? Please write in the comment section. Arey, you are standing in the intersection, then till what time the departure will continue? Till the green time. Please have some common sense. It will continue till the green time only, right? The departure will continue till green time. Okay, more smart answer. Till next red time. Okay, very intelligent answer. But in simple words, I can say till green time. So I can say the departure will continue till the green time. You see, this was your red time. Here, you see in red time, there was only arrival, right? In the green time, there will be arrival and departure. There will be arrival and departure. Now you see what happened here. Here what happened? The number of vehicles arriving became equal to what? The number of vehicles departing. You see at this point, it's a very interesting point. At this point you see what has happened. At this point, the number of vehicles arriving became equal to the number of vehicles departing. Yes, yes, because both the lines meet. Now after this, what is the meaning of this? What is the meaning of this? When the arrival rate becomes equal to departure rate, what does that mean? That whatever vehicles are coming to the intersection, they are not stopping. They are coming and going, right? I can say like that, right? When the number of vehicles arriving became equal to what? The number of vehicles departing. Indirectly it means what? Whatever vehicles are coming to the intersection, they are just leaving. There is no delay. There is what? There is no delay. Understood? Very good. Now you see, let us see a particular vehicle. This is what? This is the number of vehicles, right? This is the number of vehicles we are plotting, right? Number of vehicles. Suppose I am seeing a particular number of vehicle. Suppose I am seeing the fifth vehicle here. This is the first vehicle, then the second vehicle, suppose third vehicle, suppose fourth vehicle, suppose this is the fifth vehicle. Now you see, this was your arrival plot, right? So I can say this fifth vehicle came at T1 time, right? Yes. Since it's the arrival thing, then I can say that this fifth vehicle came at T1 time, right? Then what happened? There was red time going on, so it waited. Now, when the green time started, will it move at that point or after some time? Tell me. It reached the signal at T1 time. Now, the red time was going on, right? So, when the green time started, will it go as soon as the green time starts, or there will be some more time taken? Can you answer in the comment section? That when the green time started, this fifth vehicle will start moving, or it will take some time? After some time, it will take some time. Why? Because this first, second, third, fourth, these four vehicles will be in front of the fifth vehicle, right? So first they will move, and after that the fifth vehicle will move, and I can say that, this will be what? This will be the time of departure, T2, right? So I can say that T1 is what? T1 is the arrival time, right? T1 is the arrival time for that fifth vehicle. Now T2 is what? T2 is the departure time. It's the departure time for the fifth vehicle. That means what? The vehicle, the fifth vehicle, it waited from T1 to T2 time, right? Yes. Can I say it waited for T1 to T2 time? Yes, because it came to the intersection at T1 time. Okay. It was there in the intersection till T2 time, and then it departed. That means the vehicle had to wait for this much time. Tell me, if there was no intersection, it was just a plain road, then the vehicle wouldn't have waited. So can I say this T2 minus T1 is the delay for that vehicle, right? Can I say it's the delay time, right? It's the delay time by which the vehicle got delayed. Yes, the fifth vehicle got delayed. Like this, this was for the fifth vehicle. Now you see carefully, if you see carefully, this is the point where, this is the point on the arrival curve or arrival plot. And this is the time or point on what? On the departure. So can I say if you are finding the departure, the delay is nothing but the difference between what? The arrival curve and the departure curve. Can I say like that? Yes. So if I erase all these things, the first vehicle, suppose this is the delay time, right? For the second, this is the delay time, right? For the third, I can say this is the delay time, and so on and so on and so on, right? You can see these are what? These are the delay time for number of vehicles. I can say fourth, fifth, and so on, right? So what the total area gives me? What this shaded area gives me? Can anybody say? What this shaded area gives me? Can anybody say? What this shaded area is giving me? What this shaded area is giving me, then tell me. If I'm telling that these are the individual delays, if these are the individual delays, yes, if these are the individual delays, then what is the shaded area giving me? Yes, this shaded area is giving me the total delay of all vehicles, right? It is giving me the total delay of all vehicles. Okay. Now, how to find out this total delay of all vehicles? That will be our subject of interest in this particular lecture. So, let us start how to find out this total delay. Okay. So first, this is your vehicle arrival rate, V, right? Then we have the red time. In red time, there is no departure. So this red time I will indicate as R, suppose. I am indicating as R. This red time I am indicating as R. Okay. After the red time, there is what? There is your departure also. So the departure rate is what? S. The departure rate is S, suppose. Very good. Now, the green time started, right? This is the green time. So suppose I am telling it as G, suppose. G. Now, this green time and red time will be a total one cycle, right? It will be total one cycle. It will be total one cycle and called what? Total cycle length. This is what? Total cycle length. And that will be equal to what? C, right? That will be equal to C. Okay. So C will be what? Can I say C will be R plus G? C will be R plus G. Okay. Now you see, our intention was to find out this area, right? Yes, this will give me total delay, right? So now this area will be what? This area will be, this is a triangle, right? Now what's an area of a triangle? The area of a triangle is half. Triangle area is what? What's the area of triangle? Triangle area is half base into height, right? Very simple. Now we will study very simple geometry. Very simple geometry. Half base into height. Now see, for this shaded area, this R is the base, right? This R is the base. This R is the base. So our intention is to find out what? Our intention is to find out this height, right? This height. This height. Suppose this height I am naming as small h. Suppose I am naming as small h. So now, this is suppose small h. Then, let us see how to find out this small h. Now, derivation is not important, but if you have not seen the derivation, then many students face difficulty. Therefore, I am deriving it also, so that you not face difficulty in the examination. Now, you see, this is C. Can you tell me what will be this value? What will be this value? Can anybody say what will be this value? What will be this value? Please write in the comment section. See, you have to tell. Only I will not study. You will also study. Tell me what is this value. You see, this slope is V and this time is C time, right? Here the time is equal to C, right? So what is this particular value? Please write in the comment section. At time t, what is the number of vehicles? V into t. So here it is what? V into C. Yes, it is V into C. So can I say total vehicles? Can I say total vehicles arriving in one cycle is how much? in one cycle, because and at the end of one cycle t is equal to v. And what is the number of vehicles arrived? In the initial part of the lecture I told, now v into t, right? You solved the question 7200, you gave answer also, forgot also. Okay, so it is simply what? V into t. So in one cycle it will be v into c. Very good. Now my interest will be to find out, see, this height, right? Suppose this is h. Suppose this is h. Now can you give me this value? Suppose this is h, and suppose this is happening in time t, suppose happening in time t. This h, or I can say where the vehicle arrival and vehicle departure are same, suppose that time is small t. So what will be this value, tell me? What will be this value? What will be this value, tell me? If this is small t, what will be this value? Array, v into t, right? This will be v into t. Yes. So this will be v into t. And I can say that this h will be equal to v into t. समझ में आया कि नहीं समझ में आया? Understood or not? Array, at time, not understood, then tell me. Suppose I am giving some other name. Suppose I am giving t is equal to I. Suppose I am giving some other name. T is equal to I, where you know the vehicle arriving and vehicle departure are same. Suppose t is equal to I. Then what will be this value? What will be this value? Tell me. What will be this value? Now tell, what will be this value? If this is t is equal to I, and t is equal to c, it is v into c. So t is equal to y. What is this value? V into I. Very good. This will be v into I. And I can say that this v into I is nothing but what? This h. This h, right? Now, how to find out this I? How to find out this I? You see, we found out from this triangle, right? You see, from this triangle, we saw that this was v and this was your I. T is equal to I, so this was I. Yes. And this h we got is equal to v into I, right? You see this triangle. I can say this triangle, right? This triangle. I can find out h from this triangle also, na? I can find out h from this triangle also, right? Yes. I will just repeat it. You see. Again I will say. We got this v into I from the bigger triangle. We can also get this h. This h is equal to v into I from this small triangle also, na? From small triangle, you see this is your slope, right? S, the departure rate. And this is what? This will be how much, tell me? If this is t is equal to I, if this is t is equal to I, and this is your r, then what will be this value, tell me? Or, and this is what? Suppose this is g. Then what will be this value, tell me? So this is not t equal to I. Suppose this is t is equal to I. What will be this value, tell me? Students have got confused, so let me just repeat it. I think you have got confused. Forget it. I can understand from your faces also. I am not seeing your faces, but I am imagining your faces. You see, this is the triangle. Yes, this was V. Yes, so I told this H is equal to V into I. Yes, and this was I. Right? Now, if I see this, okay, this is what? S. The slope is H. S. What will be this value? Tell me. What will be this value? Now from the triangle, guess it. What will be this value? Very good. This will be I minus R. Yes, this will be I minus R. So from this small triangle, can I say this will be also equal to S into I minus R? Yes or no? From this small triangle, I can say this will be S into I minus R. Yes, from here I can find out this I. Again, I will say that from the bigger triangle, okay, this was V, so this became what? V into your I. Yes, because this was T is equal to I, right? And this was I from the bigger triangle. Now from the smaller triangle, this was S, and this was your I minus R. So this also became equal to what? S into I minus R. Hope everybody understood this thing or not. Everybody understood this thing or not? This equation everybody understood or not? If the answer is yes, please write in the comment section, yes, we understood this from this triangle. We played some triangle, okay? We played some triangle, okay, big triangle, okay, big triangle, okay, V into I. And then small triangle, yes, small triangle, this was S, I minus R, and this is what? S into I minus R. Yes, very good. So these two I equated. Now I will find out this relationship. So V into I is equal to S into I minus R. My aim is to find out what? My aim is to find out I. Yes, if I find I, then what will be that height of that triangle? That will be V into I, right? Therefore, I am finding I. So from here I can say V into I is equal to S into I minus S into R. Now some students might be thinking, sir, give us the final formula. But many students don't understand that if they just memorize the formula, they might commit some mistake, which we'll see at the end. So from here I can say your S into R is equal to S minus V into I. From here I can say I is equal to SR by S minus V. Now you see, now I can find out this height, right? This height is what? SR by S minus V. SR by S minus V into what? V. Because I put the value of I and then multiplied V. So I got my height, right? I got my height. Don't worry, at the end the final formula will come. And you see, I can write down the final formula also, and you can memorize also and commit mistakes also in the examination. So I don't want you to commit mistakes in the examination. Therefore I am deriving it. Okay. So this is the height we got. Why we are finding the height? Why we are finding the height? Can anybody write in the comment section? Why we are finding the height? Why we are finding this height? Tell me. Why we are finding this height? Why we are finding this height? Who will tell me why I am finding this height? Why I am finding this height? I got SRB by S minus B. Why I am finding this height? Why I am finding this height? Please tell me in the comment section. Why I am finding this height? To find out total delay. Very good. To find out total delay. Because total delay is this area, right? I told this total delay is what? Half base into height. Yes. The base is red time. So that was very easy. But I didn't know the height. But I got my height. So what will be the area or total delay? Your total delay will be equal to now half. Base is the red time and this height is h. So I can say now half r into h. Half r into h. Very good, very good, very good. So I can say now that the total delay time will be equal to your half red time into height, which was what? Which was SRV by what? Your S minus V. Now this I can write down as what? Half S R square into V divided by, if I take X common, it will be S into 1 minus V by S. Right? S's get cancelled. Now what is R? R is your total cycle length minus green time, right? Because red time plus green time is equal to total cycle time. So I can say it is C minus G. So I can write down this as what? C minus G whole square into V by what? Your 2, 1 minus Vys, right? I can further write this as what? I can take c square common. If I take c square common, it will what? C square into V, 1 minus G by C whole square divided by 2, 1 minus Vys. Yes? Now, this is what? The total delay time. This is what? The total delay time. Now, if I'm interested in finding the average one, if I'm interested in finding what? The average one. Sorry for this. If I'm interested in finding what? The average one. Average delay time per vehicle. What I will do? How I will find out? Average delay time per vehicle in cycle length. Per vehicle in cycle length. In one cycle, or I can say in one cycle. What I will do, tell me? I got the total delay. Right? And how much I got? I got that as c square V 1 minus G by C whole square divided by what? Your 2, 1 minus V by S. What I will do if I want to find out the average one from this total one? From the total delay, how I can find out the average one? Tell me. From total delay, how can find out the average one? You don't know. So I will tell you. That I can get by dividing by what? Total number of vehicles in one cycle length. Total number of vehicles in one cycle length. In one cycle length, total number of vehicles. Now, how to find out this total number of vehicles in one cycle length? You see, in one cycle length means what? This T is equal to C, right? This T is equal to C, right? If T is equal to C, what is the total number of vehicles which arrived? Tell me. What is total number of vehicles which arrived at T is equal to C? Tell me in one cycle length. In one cycle length C, what is total number of vehicles which arrived? Please tell me in the comment section. V into C, very good. So V into C vehicles. This is the total vehicles. This is the total vehicles. Total vehicles arriving in one cycle, right? And this was the total delay. This was what? This area was what? Total delay of all vehicles. Total delay of all vehicles in one cycle length. In one cycle length. And that was actually equal to how much? We got now, right? C square V 1 minus G by C whole square divided by what? 2 1 minus Vys. So if I want to find out the average one, what I will do? I'll just divide this total number of vehicles, right? So I'll just divide what? The total number of vehicles, which is what? C into V, which is what? C into V. So what will happen? You see, this VB get cancelled, this C got cancelled, we got only one C, and this average delay time is what? C by 2, 1 minus G by C whole square divided by 1 minus Vys. So this is the formula, and they ask you questions from this formula. So I derived this formula for you. Many students ask for the derivation and they don't get this derivation easily anywhere. So I gave you. If you want to understand this, very good. Otherwise, you can remember that formula also, right? Now in this formula, you see, this G is what? This is your green time. This is your green time, right? What is your C? C is your cycle length. C is your cycle length. What is your V? V is your arrival rate. It is your arrival rate. What is your S? S is your departure rate. S is your departure rate. So now you can easily remember this formula, right? Now, I'll give you some more insights to this formula and how students just memorize some things and they commit mistakes. Now you see, I'll tell you a special case. In this special case, you see what is happening. In this special case, this is your red time. Yes, this is your vehicle arrival rate, and you see this is your departure rate. This is your departure rate, and then this is your green time, and then I can say this is your total cycle length, and you can say that this is V into C at t is equal to C. Now what is the difference here? The difference here is, in the earlier case, if you see, this number of vehicles departing, yes, was meeting the number of vehicles arrived at a point before the cycle length is over, right? You see this was the case, right? You can say yes or no in the comment section. Just I understand that you are listening to the lecture. If you are sleeping in the lecture, then you can sleep also, but you can write down yes or no also, so that I will feel good. Okay, I will feel encouraged. So now this is what? This is the point where the number of vehicles was meeting what? The number of vehicles arriving was equal to number of vehicles departing. Number of vehicles arriving is equal to number of vehicles departing. Okay. So now you understand this. Now you understand this. Okay. Now you understand this. This was the earlier case. But this time t, or I can say I was getting before the cycle length was over. I was getting that before the cycle length is over, right? Now, I'm getting exactly when the cycle length is over. Yes, it's a special case. In this case, what will happen? Let us see. The average delay was how much? The average delay was equal to C by 2, 1 minus G by C whole square divided by 1 minus V by S. Yes, very good. Now see, this is V into C from the bigger triangle. From the smaller triangle, can I say? From the smaller triangle, can I say it is also your S into G, right? You see this smaller triangle? You see this smaller triangle. From the smaller triangle, this is S into G, right? Yes. And from the bigger triangle, I can say it is C into your V. Are you able to understand this? Yes. Yes. From the smaller triangle, I can say it is S into G, right? From the bigger triangle, it is what? C into V. So I can say here, what happens? C by G is equal to your, I think this was S by V, I think, equation. This is B by S, na? Yes, it is B by S. So from here I can say that your G by C is equal to what? Equal to V by S. So it's a special case. It's a special case when the number of vehicles arriving is equal to number of vehicles departing at the end of cycle length. At the end of cycle length. And I can say that if this is the case, G by C is equal to V by S. So can I write this as also in place of V by S? I can write down what? G by C. So you see this gets cancelled, right? And what I get? I get C into C minus G whole square, right? Not whole square, only G, divided by what? 2C. So C gets cancelled. What is C minus G? What is C minus G? What is C minus G? What is your C minus G? Tell me. Yes, it is red time R. So the average delay became what? R by 2. It became what? R by 2. Very important. So I can conclude from this that your average delay is equal to, very important point, and this is the conclusion which I wanted to derive, is equal to C by 2, then what? 1 minus G by C whole square divided by 1 minus V by S. Yes, now this is the formula. But when your G by C becomes equal to what? V by S, then this average delay becomes what? Simply read time by 2. Now many students just remember this, read time by 2, and for every answer they write read time by 2. No, that is the wrong concept. The correct concept is that it will be only read time by 2 only when this condition is there. G by C is equal to V by S. Or else, if G by C is not equal to V by S, then you have to go for this formula. So let us solve questions. That's it. That was the thing. Let us solve some questions. So this is your first question. Okay. The cycle length is given. I will solve 2 questions for you. Then you will solve 1 question for me. Okay. Cycle length is given as 100. Okay. The read time is given as 40 seconds. Okay, very good. So I can find out the green time. The green time will be what? C minus R, giving me how much? 60 seconds. Now you see the vehicle arrival rate. V is given as 48 vehicle per minute, and departure rate, that is S, is given as what? 80 vehicle per minute. What is the question? The question is average delay per vehicle. So how to find out the delay? For that, first thing you have to check is what? Your G by C is V by S or not. So, please find out and tell me, is G by C is equal to V by S? Please tell me, is G by C is equal to V by S? Please mention in the comment section. Is G by C is equal to V by S? Yes, it is. How? You see, G by C is how much? 60 by 100, that is how much? 0.6. That is 0.6. And what is your V by S? Your V by S is 48 by 80. I can divide by 8, which is 6 by 10, giving me what? 0.6. So first is always you check this. It is equal. And when it is equal, the average delay will be simply equal to what? Read time by 2. It will be simply equal to read time by 2, that is equal to 40 by 2, that is equal to how much? 20 seconds. So this is a very straightforward question. But see, we applied read time by 2 only after checking this condition. Only after checking this condition we applied this. Okay, without checking the condition, don't apply, will be wrong. You might be wrong, you might be correct, you might be wrong, right? It's a 50-50 chance, so don't take a chance. Okay, check this condition always. And therefore, you see, I derived everything for your understanding, right? I could have directly wrote this formula and solved and completed the session in 15 minutes. I could have just wrote this formula and complete the session in 15 minutes. But I rather preferred to derive this equation so that you get a complete clarity of what, why and what. And that is how you crack GATE. And not crack only. Doesn't mean you get a 40 or 50. You have to get 80 plus. So for getting 80 plus, you have to be thorough in your concepts. Okay. So now, so we solve this question very easily. Let us understand this question from graph also. Let's understand this question from graph also. You see, this was your 40 seconds, the read time, right? And you see, this was your 60 seconds, the green time. And you see, if I see, this was what? 48 vehicle per minute. And this was what? 80 vehicle per minute, right? So what will be this point? Tell me. If I calculate from V into C, tell me. If I'm calculating from V into C, V is what? 48, okay, into what? 48 is vehicle per minute. I can convert to seconds what? By 60 vehicle per second into 40. How much I'm getting this? Let me see the question. Okay, I have to take 100 seconds, right? I have to take 100 seconds. V into C, I have to take 100 seconds. This should be 100 seconds. So if it is 100 seconds, then what is the answer? This will be 80, right? V into C is 80 vehicles, right? V into C is 80 vehicles, right? Right? And then if I am calculating from G into your S, from G into S, yes, this was G and this was S. G into S is how much? 80 by 60 into 60. Again, I am getting how much? 80 vehicles. You see, again, I am getting how much? 80 vehicles. That means what? That at the end of the cycle, this number of vehicles arriving is equal to number of vehicles departing. And this is also right. How we check this condition? Instead of checking, VC is equal to GS, I can also check what? G by C is equal to V by S or not. So if this is the condition, that means what? That means at the end of cycle length, the number of vehicles arriving and number of vehicles departing is matching. And you can see that now I can easily calculate from the graph also. How? You see, if this is the case, this was how much? This was 80, right? So this height is 80. This height is what? 80. And I can say this is your red time. So total delay will be how much? So from this I can say the total delay will be, red time was how much? 40. So half 40 into 80, giving me how much? Giving me 1600. So total delay is 1600 and the average delay will be how much? So I can say the average delay will be 1600 divided by what? Number of vehicles, that is 80, that is how much? 20 seconds. Now this graphical understanding I am giving just for your understanding. No need to actually understand the graph also, but now you have understood the graph, that means you are extra smart now. You are less prone to commit mistakes, right? Or more confident about the examination, right? So instead of the graph, you can directly go for what? Checking the condition of what? Your V by S is equal to G by C or not. If that is the case, directly go for what? Red time by 2. But it might not be the case every time, like the next question, the question number 2. In the question number 2, you see the cycle length is given 30 seconds. The red time is given 30 seconds. That means what? The green time is 30 seconds. Very good. Sorry, it's a mistake. It's not 30 seconds. The cycle length is 60 seconds. Okay. Typing mistake. Always happens. No problem. So cycle length is 30 seconds and red time is 30 seconds. So green time is what? Green time is also 30 seconds. Right? Now you see, this is your vehicle arrival rate and this is what? The departure rate, S. Now again I will do the first check. What? Is G by C is equal to V by S or not? Please check and give me the answer. Is G by C is equal to V by S or not? Is G by C is equal to V by S or not? No, that's what I wanted to tell. If you just remember this formula, red time by 2, you will commit mistake. This red time by 2 average delay, is only applicable when G by C is equal to V by S. Very important concept. But now you will not commit mistake because you have learned from me now. So this is not equal. G by C is how much? 60 by 180. That is what? 0.33. Whereas your V by C is how much? V by S is how much? Sorry, this is V by S. Whereas your G by C is how much? It is 30 by 60. That is how much? 0.5. So they are not same. So when they are not same, what you will do? You have to go for what? The original formula, that is what? C by 2, 1 minus G by C whole square divided by 1 minus V by S. And this will give me what? The average delay. So this is C by 2, 60 by 2, 1 minus G by C. G is how much? G by C is got also value, right? G by C we got 0.5 whole square divided by 1 minus V by S. That is what? I am getting 1 by 3 actually. So this is 2 by 3. Okay. So how much I am getting this average delay? Then tell me 11.25 seconds. I am getting how much? 11.25 seconds. Whereas, what is red time by 2? What is red time by 2? Red time by 2 is 15 seconds, right? Red time by 2 is what? 15 seconds, right? In this question, it is 15 seconds, right? Yes. It is 15 seconds, right? Yes. And therefore, you see, these two are not same. So the average delay will never be always, I can say equal to what? Red time by 2. You have to always go for this check. Understood this check? Always go for this check. Very simple. This is the formula. Applicable when G by C is not equal to V by S. If G by C is equal to V by S, then average delay is what? Red time by 2. Simply. Understood? So we solved 2 questions and we understood this concept. Now you will never commit mistakes on this. Okay? We'll never commit mistakes on this. So you see, I'll just tell this in fast way. This was 30 seconds, right? This was 60 vehicle per minute, right? This was your 180 vehicle per minute, right? And then I saw this was also 30 seconds, right? Now you see, if I find out the number of vehicles in the total cycle length, that is what? V into C. How much I'm getting? That will be 60 by 60 into 60, right? Because 60 vehicles per second into 60, I'm getting how much? 60 actually. V into C, I'm getting how much? 60, right? Now, you see, can I find out this time T? Can I find out this time T? Yes, I can find out time T. How? In this time T, I can say that V into T will be equal to S into how much? If this is T, then this will be how much? This will be T minus R, right? So T minus R. So I can say 60 into T is equal to 180. T minus R is how much? 30. So from here I can say 60T is equal to 180T minus how much? 5400. So from here I can say 120T is equal to 5400. How much T I am getting? How much T I am getting? Tell me. How much T I am getting? It is the time when they are matching. And they might ask a question like this. See, always they might not ask you find out the average delay or total delay. They might ask you find out the time. Yes, this might be a question, right? Find out the time when the number of vehicles arriving is equal to number of vehicles departing. They might ask this question also. And from here I am getting T is equal to 45 seconds. I'm getting T is equal to 45 seconds. So if T is equal to 45 seconds, this value will be how much? This height will be how much? This height will be equal to V into T. So 60 vehicles per minute. So 60 by 60 vehicle per second into 45. How much I'm getting? 45, right? So this value is how much? 45. So I can erase this, all these things. You see this is 45, right? This height is 45. And you can see that if I'm finding this area, total delay, this total delay will be how much? This total delay will be half 30 into 45. But if I'm finding the average delay, I have to divide by how much? 45 or 60? If I have to find out the average delay per cycle, I'll divide by 45 or 60, tell me. If I have to find out the average delay, 45 or 60, tell me. 45 or 60, average delay, 45 or 60. Which one I will divide? 60. Very good. Because in one cycle length, 60 vehicles are coming, right? So divide by 60. You can see you will be getting how much? 45 by 4. Again, 11.25 seconds. So you can solve the question graphically also, or by using the formula which I told. Now why I solved this graphically? Because in the examination, they can also ask this time also, na? See, you are memorizing the formula. You're just memorizing the formula. Okay, average delay is equal to and you know some very smart people are remembering only red time by 2 without understanding the concept, right? Then what will happen? First mistake they will do is that they will just write down red time by 2 and khatam. Answer galat, wrong answer, right? Or in the examination, they might not ask you only find out the average delay. They might ask you a question that find out the time when the number of vehicles arriving becomes equal to the number of vehicles departing. And that time you cannot solve the question because you have not understood the concept, only memorized the previous year question, that too without any, in-depth understanding, and then you might end up getting 50-60 marks in the gate, and you might not get 80 plus. So if you want to get 80 plus, then you have to study in the manner of 80 plus, right? Very good. So now solve this previous year question, a very easy question. Please solve this question. This question came in GATE 2019, and you can see that you can solve this question within 1 minute. Let us solve this question very fast. Meanwhile, I'll also solve this question, but I'll wait for you. Let us see how many solve this question very fast, very fast. Now you see, these questions will appear very easy for you. Once you have understood the concepts, then this question might appear very easy for you. But as I told, only solving previous year question won't help. You need to understand the things in details, like the way I taught in this particular lecture, deriving the whole formula, understanding the whole curve, so that anything they ask from the curve, you're able to answer. Yes, if you want to get 80 plus, you want to get 85, then this is the right motivation. Understand in details. Don't only solve previous year question. Yes, solving previous year question is very important, that you get an understanding of what is asked in the examination. But apart from that, it is very important that you understand the in-depth concept behind that. So what is the answer? Why so much of time is taken by the students? Okay. Please solve this question. The last question, and the session will end. Arrival V. Service rate is, that means what? The other one will be the departure rate, right? So V by S is how much? 20 by 50, that is how much? 0.4, right? Now G by C. G is 30, total cycle length is 60, so G by C is 0.5. So these two are not equal. Yes, that cross sign, you know, that sound comes in a lot of movies. Okay, so it's not equal. That means what? I have to go for this formula. 1 minus, I can say C by 20 is how much? 30, then 1 minus G by C whole square divided by what? 1 minus V by S. So you solve this, this will be 0.6. I can say this will be your 50. Yes. Then 50 divided by 4, I am getting how much? 12.5. I am getting 12.5. Right? You see, so easily we are able to solve this question by just understanding the previous concepts. Very good. So easily you are able to solve. Now if you have understood this type of questions in depth, then whatever might be the length of the question, your answer length will be small. The question length is more, but the answer length is small. That is what is smart studies. That is what is real motivation. Now many students ask me, sir, how to keep myself motivated? The right way to stay motivated is what? To understand and study in a smart manner. If you study in a smart manner, then all these questions will appear very easy. That will lead to what? You know, right motivation. If you are just memorizing and you know you are collecting notes, making your studies a pothy, then you know you can't get motivated and motivation will end. So that is right motivation is what? Understand the concepts rightly. So therefore, this was a lecture. So tomorrow we will be seeing what? The vehicle damage factor at 5 p.m. So stay tuned. Please study very sincerely. So tomorrow we have vehicle damage factor from your design of flexible payments. Today we studied traffic engineering, an important concept of your delay model. In that we studied the average delay per vehicle and the total delay, right? So tomorrow at 5 p.m. we are going to study this. Thank you very much. Bye. So I'll just wait for our technical team to end the class. Till the time, you can say good words about me if you want to say. Thank you very much. Thank you Surya, Rahul, Akanksha, Juhi, Samriddhi, Vivek, and everyone. And all the students who are listening to the lecture recorded. Thank you very much. Bye.